Hey guys, this is Jim with Performance Technologies. We'll be talking about our 300ZX project today. The car was bought for $600. It's well worth that kind of money just from the condition of the body and interior parts. Has been hit in the nose at some point, and then someone did just an awful job trying to repair it. You can't see it with the sheet metal or nose on, but it's pretty beat up underneath. So we'll have to fix that a little later. It does have a really nice set of wheels and tires on it. The wheels alone are worth a hell of a lot more than I paid for this car. We have the engine out and all torn down. It's ready to go to the machine shop. The number 2 cylinder has some pretty good damage in it from debris and trash getting down into the cylinder, probably from someone pulling the spark plugs and not cleaning out the spark plug wells beforehand. It's a pretty common problem with these cars. Crank is in excellent condition. It just needs a micro polish and it'll be just fine. What you're seeing is reflections and not any scarring or anything. This is a zero index crank, which means there are no undersized bearings used from the factory. Nissan does use undersizes in 4/10,000ths of an inch increments so that they can blueprint these things from the factory. But this is all standard. It's a zero index crank, so we don't have to worry with anything like that. The pistons are another story. They're trash. 3 of the pistons had cracked ring lands. You can see lots of damage on the skirts, stuff like that. So they'll be replaced and the block will be bored 20 over for the new set of pistons. The heads weren't horrible. The kid that had it prior to us had overheated the car. It blew the driver's side head gasket and warped that head by about 6/1000ths. So both heads have been milled and all the valve work has been done. The ports have been gasket matched. We also polished up the combustion chambers and polished out some of the shrouding around the valves. Yeah, you're not seeing things. This is an automatic transmission car. I know you're laughing at me and you think I'm crazy, but these Jatco automatics will just hold a hell of a lot more power than you people give it credit for. All that it needs is taking some time and being careful in the rebuild. It takes a little bit more money and quite a few valve body modifications to make it survive, but these will handle about as much horsepower as a Chevrolet Turbo 350 when they're built correctly. We're not going to make tons of horsepower on this car, so it'll be fine. This is something you may not be aware of. This is a Z31 lower intake manifold with a Mitsubishi 3-liter dual overhead cam fuel rail. Yes, the spacing is the same on the injectors. The biggest difference is that it's a nice size fuel rail. It'll handle lots of horsepower. It uses standard 11mm O-ring top injectors that you can get anywhere, and it's a hell of a lot cheaper than aftermarket fuel rails or having to go through the hassle of trying to build your own custom fuel rails. They're available in just about any salvage yard. They're dirt cheap or free. There's no reason not to use them. We'll do a video of the modifications later on. It's pretty simple to do. These are the injectors we're using. They are 11mm top O-ring style. They're 440cc full set, and they are flow matched so that each injector flows the same rate of fuel. The interior in this car was in really nice shape. The carpets, the weather stripping is all excellent. The dash is perfect. There's no problems there. The seats were trash, so we've removed them and replaced them with these Sparco style seats. They're a black velour with red trim thread. They look good in the car and they feel good. We custom built the mounts and raised the position of the rear seating about 3/4 of an inch to give you a better view over the nose of the car. This is a GLL, so it has the digital dash and almost every option you could get, including headlight washers. Gauge pod is mounted to the pillar. It contains the air-fuel ratio meter and the exhaust gas temperature meter. All of the elements in the digital dash now work. As I said earlier, The dash is just in really nice condition. It was probably a garage kept car. There's no cracks, no warped edges. The thread is all looking good. It's just in very nice condition. Since the nose of the car was hurt, we've cut this nose section off of a donor car. It'll be spliced back onto this car. Everything lined up and re-straightened again. Here's a view of some of the tinware that's been painted up and ready to go back onto the car. This is our shop girl. This is Boo, the super cat. She makes sure that we do everything correctly around here. Quality control, you know. This is the drive shaft that we're using for the car. It's a 3-inch seamless steel unit. Uses heavy-duty truck U-joints. They're now fully replaceable, and it should handle about 650 horse. What happens when you take one of these and two of these and put them together? Well, you get one of these. This is a 3-core Champion all-aluminum radiator. It has two 12-inch 1400 CFM fans to keep everything cool, and it's a direct bolt-in replacement for the factory radiator. This is the turbo we'll be using. The only modifications that we still need to make is to change out the center section housing. Right now it's an oil-only cooled turbo, and I prefer to use water-cooled when these are going to go in a basically stock location. I'm not sure where the location will be yet, but it will still be sandwiched between the block and the inner fender wells. So we'll change out that center section, make sure it stays cool and happy. It's a T3 T4 hybrid. Uses a TO4E compressor side. It's a 55 trim. It's a 2.5, a little over 2.5 inch inlet. The exhaust side is a P trim turbine wheel. It does not have an integral wastegate. We will be using a external wastegate. I'll show you that here in just a minute. Here's a look at the flanges that we'll be using. These are 1/2 inch stainless. The 4-bolt flange on the left is for the manifold turbo. It welds onto the new turbo manifold that we'll be building. The one on the right is for the back of the turbo. That's where the downpipe comes out of and goes to the exhaust. The two bungs you see there, the top one is for the O2 sensor, the bottom is for the exhaust gas temperature sensor. We'll be using these L's, T's, and some straights to build that new turbo manifold. These are 3/16 stainless. They're an 1.5 ID tubing, 1/8 wall thickness, and when this is finished, it's hard to imagine now, there'll be a wastegate port mount on the top, and the turbo manifold flange will be on the bottom area of this manifold with a little box collector also. It'll make for a nice setup. These are the manifold to head flanges that we'll be using. They're 1/2 inch hot rolled steel. There shouldn't be any problem using the steel with stainless steel tubing. We'll just use stainless steel stick when we weld them all together. The stainless steel studs that are being used for the exhaust manifolds as well. These will go on both sides of the car. It's a full set. These are 38 millimeter long and they're 8 millimeter diameter with stainless nuts. This is the blow-off valve we'll be using on its intercooler mount. This goes between the intercooler and the throttle body on a turbo car. It protects the turbo from shock if you close the throttle quickly or when you change gears. The system can overpressure because the turbo is still making boost and there's nowhere for that boost to go. This allows that boost to escape. Otherwise, the overboost condition can cause the compressor side of the turbo to try to stop, and that usually rips blades off the compressor wheel itself. We don't want any of that. This is the wastegate we'll be using. It's a teal 44 millimeter unit. It's bigger than we need for this project. 38 millimeter would have been just fine, but there's no real downside in using too large of a wastegate. Also, I lucked into this one. that's a new condition. It's never been used on a car. It's been mounted on a car as mock-up, but it was dirt cheap and I just couldn't refuse it. The wastegate's job is to keep the turbo from overspooling by allowing too much exhaust gas to go through the turbo, making it spool too fast for the bearings to handle and burning itself to the ground. It does that by bypassing a large part of the exhaust before it goes through the turbocharger and venting it into the exhaust system after the turbocharger, bypassing the turbo altogether. It's adjustable, but most of the time you're going to use a manual boost controller. On this case, we're using an electronic boost controller that will handle all that work. This is the intercooler we'll be using. It's 27 3/4 inches wide and 11.5 inches tall. It's a 3-inch core unit, bar and plate. It's a 2.5 inch inlet and outlet, and has upper and lower mounts on each side. And since this is an automatic transmission car, we need a way to keep the transmission happy and healthy. This is an inline Hayden 1405 transmission cooler. It goes between the intercooler and radiator in the airflow. What you're seeing now is a 255 liter per hour fuel pump. Keep those bigger injectors well fed. Make sure the car doesn't lean out. This is an in-tank unit, and it's a direct replacement for the stock Nissan unit. All of that new fuel flow has to be regulated, and that's what this device does. This is a fully adjustable fuel pressure regulator with boost reference. As the boost comes up, so does the fuel pressure. This is also adjustable, so you can set your base fuel pressure rates. It's pretty important to do that. What can I say about Arp Rod Bolts? They're just cheap insurance. I never build an engine without one. I also never reuse rod bolts on an engine that has any miles on it at all. It's just too cheap not to build into your budget. Bearings we'll be using, these are the mains and the rods. They're Clevite 77. Since the mains on the crank are all 0 index, we can easily get away with using just a standard bearing. Don't have to worry about any of the undersizes or matching them. The final item on this version of our little show and tell are the solid motor mounts that we'll be using. These are solid aluminum. They'll replace the factory rubber biscuit style that are about 4.5 inches in diameter and just get in the way of everything. This is not going to be a supercar. The goal for this car is to be a nice street cruiser with good power. The target is 350 to 375 horsepower at the tires. That's easily attained on a stock internal engine with just bolt-ons, but we tore this thing down because we needed to know where we stood after we bought the thing. That's it for the overview. We'll post more videos as necessary, including some of our component builds and how-tos such as the fuel rail and that sort of thing. For more information, go to the website. Have fun, drive safe, and we will see you guys later.